Thank you for organizer for giving me a chance of this talk. My talk is a little bit different from the previous talk related to the limitation of balance. We investigate spontaneous gravity realization from nearly balanced rotational flows in a shallow water system. We focus on the effect of Earth rotation, precisely the latitudinal change of Earth rotation in the spherical shallow water system or rotating. And this work is collaborated with Katsuya Ishii Nagoya University, Hiromichi Kobayashi and Yutaka Shimomura, Keio University. And here is the outline of my talk. I will mention briefly the concept of balanced flow. And balanced flow is breaks down due to the spontaneous gravity realization. And we show the previous results using F-plane shallow water case. To extend the previous work, we use spherical shallow water system on a rotating sphere, and we focus on the effects of the latitudinal change of the Earth rotation. And to analyze the result, we use gravity wave source and its analysis using analogy with the light field theory of the vortex sound. Okay, let's move to the motivations. The concept of the balanced flow is the counterpart of nearly incompressible fluid in aerodynamics. In aerodynamics, the all significant dynamic information is contained in three-dimensional vorticity field. That means we neglect the contribution of sound waves that we can treat fewer degrees of freedom in vorticity field to derive information on the general flow. So in the balanced flow, in the atmospheric or oceanic flow, vorticity field is replaced by potential vorticity, and sound waves is analogous to the gravity waves. So we can derive all significant dynamic information by potential vorticity inversion. So this concept is a very powerful tool to understand the Rossby wave phenomena by using potential vorticity sinking. So in the past more than 2 decades, there are several studies related to balanced flow, and nowadays the exact slow quasi manifold, which is free from gravity waves, non-existence. But this topic is more important because what happens if the balance is broken, or how much balance is maintained in the wide parameter range. So there are several studies related to balance regimes. For example, Sparrow and McWilliams investigate shallow water turbulence with initially balanced conditions. They obtained in the wide parameter range there are 2 balanced regimes. Previous study, we also investigated the linear stability and nonlinear simulation in the jet flow in F-plane shallow water case. And these are examples of our study. We get if this is a shallow water system, and it's a quasi-geostrophic approximation of the shallow water system. And if full number is sufficiently small, quasi-geostrophic approximation is still valid highly nonlinear phase of and highly high Rossby number case. But for sufficient enough high full number case, there are significant difference between shallow water system and quasi zero source system. This is animation of 3-parameter range, relatively high full number case and small low full number case. And Rossby number is 100 and 0.1. You see that this is a good balance relation, but significant difference appeared for highly nonlinear phase. So this difference is maybe due to the gravity wave radiation from nearly balanced flow. By the way, gravity waves is very important for atmospheric science. They propagate far away from the source region to the middle atmosphere. They drive global circulation in the middle atmosphere. Thus, to simulate future climate, we have to know the process of gravity waves, radiation, propagation, and dissipation precisely. In this study, we focus on these radiation from polar night jet and cyclones, which is strong rotational flows. These gravity wave radiation is considered as the spontaneous gravity wave radiation. There are several observational studies suggest that the gravity wave radiation is occurs from polar night jet, subtropical jet, and hurricane. And this is different from traditional geostrophic adjustment process, because geostrophic adjustment, we assume the initial unbalanced state, but these are initially mainly balanced rotational flows. That's gravity waves are radiated from nearly balanced state, so the difference from geostrophic adjustment. To explain, to investigate spontaneous gravity wave radiations, there are several experimental and numerical studies using DCM and mesoscale models like this. Another approach is using the simplified model of F-plane shallow water system. This system is the most simplified system, which includes gravity waves and rotational flows. In addition to this simplicity, this equation is the same as two-dimensional compressed gas fluid if the effect of Earth rotation is negligible. So gravity waves are analogous to the sound waves. We can use light hill theory of vortex sound. Ford pioneering work analyzed the source of gravity waves. This is the exact equation using F-plane shallow water system. And right-hand side means gravity wave propagation, and left-hand side, right-hand side is regarded as the source of gravity waves. To calculate far field, we can get gravity wave amplitude using historical integral in the time direction. And using scaling analysis, we can get full number power law, which is correspond to the power law, well-known power law Mach number if the effect of Earth rotation is negligible. In the previous study, we use F-plane shallow water system, this zonal jet type basic state, and we obtain continuous gravity wave radiation from these unsteady rotational flows. Here is the surface displacement, and we can see the continuous gravity waves radiation occurs in the rotational flow. We also sweep the parameter, and we get the full number per row of gravity wave flux. Here is vertical axis shows gravity wave flux, and here is the full number, which is that if the Earth rotation is negligible, that means higher Rossby number case, which obtains a linear per row full number. But middle range of Rossby number, which is at the breakdown of the per row full number. It's the effect of Earth rotation. We also see that the Rossby number dependency of gravity wave flux, and there is sudden decrease of gravity wave flux for smaller Rossby number, and we also see that the local maximum at Rossby number 10 case. This is not anticipated by the classical light field theory. So we analyze source of gravity wave in the frequency spectral analysis. Here shows the each color shows the this source term, and there is a frequency spectra, and horizontal is frequency, and we can see that each Rossby number case, blue color related to vortex source is almost constant, but they are related to the Coriolis term source increase for smaller Rossby case. One thing we have to note is that the cutoff frequency of gravity waves, that means only higher frequency mode than the cutoff frequency gravity wave can propagate. Thus, there is no gravity wave radiation propagation for small Rossby case. In the middle range of Rossby number case, while the peak is larger than the source related to vortex term, but the cutoff frequency is enough sufficiently smaller than the peak of source related to Coriolis term. That is the reason why local maximum of gravity wave flux appears. So, to summarize of our motivation, we are interested in the limitation of balanced flow due to the spontaneous gravity wave radiation. And previously, we fixed the F-plane, so the effect of Earth rotation is fixed. So, if we use a spherical shallow water system, effect of the Earth rotation is changing at the latitude. So, here we investigate the spontaneous gravity wave radiation in shallow water system on a rotating sphere to focus on the latitudinal change of the Earth rotation. One thing we have to note is that the energy of gravity waves is far smaller than the energy of rotational flows. So we have to use a special numerical scheme with high accuracy and resolution. So in the next few slides, we will show the recently developed high resolution scheme. Here, numerical schemes. In the previous study, we used spectral schemes, which has high accuracy and resolution, but not usable for parallel scalar machine because the tendency of supercomputing system is nowadays parallel scalar machine. So we have to use another scheme. There are several finite difference schemes with high accuracy, and these combined compact difference schemes has high accuracy with few stencils. In these schemes, we use these higher derivative terms combinedly and solve. We achieved high accuracy. And recently, one of the authors have developed the spectral-like CCD schemes, which achieves high resolution in Fourier space.
ECMWF are running their spectrum model very well on that type of computer.
Yes. And we solved spectral-like combined compact defined schemes using this diagonal matrix form. And in this equation, we solve each latitude and longitude separately. We have parallel efficiency. And here is the computation time compared to spherical harmonic spectral models. We see that our schemes is depend on the n square, while the spectral schemes depend on n cubed. So about 100,000 grid points, our schemes have much efficiency than the spectral model. It's only one CPU case. We, as we mentioned before, our schemes has parallel efficiency. Okay, let's move to the experimental setup. We use auto equation on a rotating sphere. We put these additional terms. It's a relaxation forcing term to maintain zonal jet flow. Here is a basic state, and basic state is basic flow is balanced with surface displacement. That means gravity wave radiation in this system is spontaneously. And this jet flow satisfies a necessary condition of barotropic instability. And here is the resolution set to with these values. And we also put the low pass filter for higher latitude because grid concentration around the pole. This is a counterpart of hyperdiffusion time in spectral models. These are parameters of the Earth, and we define the non-dimensional parameter using the basic state of Z. We sweep Rossby number and the position of the Z in this study. Okay, here is the time evolution of the flow field. Initial Z flow rolls up because of the barotropic instability, and zonal forcing maintains the zonal jet flow. And we see that divergence field gravity waves are continuously radiated from jet region. And here we investigate the latitudinal dependence of flow fields at relatively high Rossby number case. As you can see, wave number of vortex decreases at higher jet latitude due to the shortening of the longitudinal length of the Earth. Here is the gravity wave flux at relatively high Rossby number case. The vertical axis is gravity wave flux, and horizontal axis shows the position of the jet, low latitude and high latitude. We can see that here is color shows observational point latitude from equator to the higher latitude in the southern hemisphere. We see that total amount of source decreases moderately due to the shortening of longitudinal length at higher jet latitudes. Thus, the gravity wave flux depends on like this. On the other hand, for relatively low Rossby number case, gravity wave field is significantly different from high latitude, high Rossby number case. You see that the vertical field is almost the same, but gravity waves are very different from the latitudes and previous Rossby number case. And here is the gravity wave flux. You see that the gravity wave flux decreases suddenly from low latitude Z. And for higher latitude case, gravity wave radiation almost inhibit, and no gravity waves are radiated from high latitude Z. So to discuss the result, we use gravity wave source with using F-plane approximation in the Z region. Here is the source term. It's a snapshot of the source. We can see that the source related to vortex is dominant, while source related to Coriolis term is not negligible. It's this is correspond to the previous F-plane study. And we also analyze frequency spectra of gravity wave source. This upper panel shows Rossby number 10 case and Z latitude 22 and 67, and lower panel shows low Rossby number case. You can see the gravity wave source is not so much affected by the change of parameter like this, but cut-off frequency is very much different from Rossby number and position of Z. Thus, if we put the low latitude Z, gravity wave can radiate it, but they doesn't propagate higher latitude because cut-off frequency is larger, higher for higher latitude on the southern hemisphere. And if we put higher latitude of Z, there is no gravity wave radiation. Only higher frequency tail can radiate gravity wave. So to summarize this study, we investigate spontaneous gravity wave radiation from N3Z using high accurate numerical schemes. And gravity waves are observed on the southern hemisphere, and flux depends on the latitude of Z. And we analyze the result using the F-plane approximation and light field theory. It's useful to discuss the spontaneous gravity wave radiation. So for future work, we now do the two-layer model to simulate internal gravity wave radiation from baroclinic unstable jet flow. And in this system, we have short wavelength gravity waves from the baroclinic unstable jet. And this is more realistic than the only external gravity wave case in the shallow water models. And for future, we parameterize this possibility of parameterization of this spontaneous gravity wave radiation. And finally, we also analyze the analytical estimation of wave field. Ford used matched asymptotic expansion for this parameter case and obtained a wave field like this excision. And we can get for simple basic flow type vortex pair or Kirchhoff ellipse vortex, we get analytical estimation of far field. So next we analyze numerical and analytical solutions. It's better understanding to vortex sound and gravity wave radiation. Thank you.
We have time for a question or two. Michael.
I mean, it's wonderful that you verified those complicated calculations by Rupert Ford. But then in his earlier paper in '94, and you've showed us a simulation like that, in which you were getting the power law for the radiation. If I may be misreading your graphs, but we were expecting a power law, a sixth, sorry, that's the energy, so it would be the third, I think. In 2 dimensions, it's the fourth power of the Froude number in dimensionless terms. corresponding to a Lighthill 7th power law for the energy radiated. But yes, so in that plot,
Yes.
is that in disagreement with what we found?
We fix this zonal jet flow. So the power law depends on the only fundamental mass. We only sweep the Earth rotation. We fix the jet flow,
Okay.
but changes Earth rotation.
Okay, so you didn't
And we also use fluid number is changed by the depth of the fluid.
Yes.
So the fixed U0 means there is fluid number power law order 1.
Perhaps we should discuss it afterwards. I'd like to check that point.
I think perhaps we're ready for lunch, so let's resume back here at 2 o'clock and let's